All right. Now, whenever you're simplifying a radical, there are times when you need to use absolute values because when we talked about principal roots before, if you find the square root of 49, you have two roots. You have a 7 and you have a -7, where 7 is your positive principal root. And so to denote, like if you have a negative root, or answer to a square root, then you need to put absolute values around it to show that you can also get a positive value. So this only happens when you get an even root of an even power. Okay, that's the only time it ever occurs. No other time will happen. So if you have an odd power, it is automatically, you don't have to worry about any absolute values. So if you find an even root of an even power and the result is odd, ooh, so many evens and odds, rough, you have to use absolute value signs. Okay, so if we look at example 2 here for A, notice we have an even root and we also have an even power. So we're going to take an even root of an even power. If our answer is odd, then we'll have to use absolute values. So if you take a 6 divided by 6, so the inside power divided by the outside, 6 divided by 6 is going to give you a t. Well, our result has an odd power because our result would be t to the first. So that means we would have to use absolute values around our problem. So you're going to need to write your answer as the absolute value of t. You don't have to put this 1 up top, but I did just to show you. Okay, so let's look at the next problem here, where you're going to have to simplify the fifth root of 243 and the fifth root of x plus 2 to the 15th. So we know that the fifth root of 243 is going to end up being a 3. And then you have the parentheses, x plus 2, nothing happens inside here. And then you got to take 15 divided by the 5, so that means you're going to get a 3. Now we get, alright, now here's the thing though. Since your even index was originally a, since your original index was an even, or an odd number, you don't have to use absolute values because your index is odd. So in this case, 3 times the quantity of x plus 2 to the third power is your actual answer. No absolute values required. On C, you have a negative out front, so you're going to have a negative in your answer when we find our solution here. So we have a negative, and then you have parentheses of 3x plus 1, that doesn't change. And then what we're going to do is you're going to take the 6 on the outside, divided by 2. Well, we have an even power, and we have an even index, so that means that if our answer is odd, we will need absolute values. So 6 divided by 2 is a 3. So since we have an odd power as our root, you will actually need to put in absolute value sign. So just the 3 plus 1 will need to be in absolute values. The negative outside is not, because it was already outside our function. So then finally for D, if we simplify this, we're going to end up taking the fourth root of 16, which is 2, and then we have x minus 3 in parentheses, and we're going to take 12 divided by 4, this 12 divided by this 4, which will give us a 3, and since we haven't, we want even, okay, we had an even value here, even power, even root, and we're going to get an odd exponent. We need to put in absolute values. So you should have the 2 outside with the x minus 3 in absolute values for your answer. Not parentheses, absolute values. Here we go, can I make them better? And that is how you use absolute values.